Video number 229, common denominators and equivalent fractions. If we took 1/4 and we were to talk about the equivalent fractions of 1/4, we would want to take a look at some pictures. First thing we have here, this is 1/4 right here, or any of these pieces here. This is obviously 1/4, this part of the circle. Then of course, what if we took these fourths and divided those in half? So we take these fourths and divided them in halves. We would have eighths. So that same section of the pizza or the wheel, whatever you want to think of this, is now the same exact size, but we're talking about it in different increments. Now we're talking about these denominations as being eighths, which is why there's two of them inside of a quarter. So 1/4, 25%, is two of those 1/8. All right, so these are two equivalent fractions. We might come back to this in a few moments. Here's 2/3 perhaps. 2/3 would definitely look like this. Okay, there's 2/3. Now, what if we were to take 2/3 and divide each of those thirds into 3 more pieces? So we were to take those first 2/3 and divide that up. So now you have 1, 2, 3. Well, this is a little bit off. That's all right. So 1, 2, 3. So I took the second third and divided that into 3 equal pieces. So 1, 2, 3, 1, 2, 3. So now what happens is, instead of us referring to this portion of this rectangular block, we would now, instead of calling it 2/3, we have 1, 2, 3, 4, 5, 6 out of 7, 8, 9. So we have a total of 6 out of 9. So 6/9 is equivalent to 2/3. Okay? So these are just the equal denominations. Okay? I'm sorry, different denominations but equal fractions. Here we go. 2/3 and 10/15. Now here, this is interesting here. Now we're going to take our 2/3 here. All right? And we're going to divide it up into 5 equal pieces. So now, look at this. 1, 2, 3, 4, 5. Same way. 1, 2, 3, 4, 5 more. So look what you have here. 2/3 is the same as 10/15. I guess I need to rewrite this. We'll call this one 2/3, that one 10/15 now. But of course, they're equivalent fractions, so that's why it doesn't really matter. This is the picture of 2/3. This is the picture of 10/15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 15. Notice how it's covering the same amount of ground. Okay, next one, discovery. We have now discovered that equivalent fractions have the same multiple for the numerator and denominator. Let's go back and take a look. If we multiply both the numerator and denominator by 2, you get 2/8. If you multiply both the numerator and denominator by 5, you get 10/15. Multiply the numerator and denominator by 3, you get 6/9. Notice here also that when we multiply both the numerator and denominator by 2, notice how we took the one piece and made it into 2 more pieces, right? We took that one piece and then divided it by 2. Here, you took our 1/3 and divided it into 1, 2, 3, 4, 5 pieces. Notice how we did 2 times 5, 3 times 5 as a discovery. Same thing here for the 2/3 to become 6/9. We took our one block and divide it into 3 pieces. Notice how 2 times 3 is 6, 3 times 3 is 9. So that's how we could find the common denominators, as we're going to discover that this is called later on, common denominations, common increments, and that's how we get these equivalent fractions. So, in order to add 2/3 and 1/4, we would need to divide the thirds into 4 pieces, right, to get 12ths, and then we would need to cut the 1/4 or the quarters into 3 pieces, so then we could have 12ths. See, we cannot add 2 different increments. You cannot add feet plus kilometers unless you convert one to the other, okay? So 2/3, we would take 2/3 and multiply it by 4/4, okay? And then we would take our 1/4 and multiply it by 3/3. Here you go. And we would end up with 8/12 plus 3/12. All right. So we essentially took our 2/3 and made it 8/12. That's the equivalent fraction by multiplying by 4/4, or in other words, cutting the thirds into 4 more pieces. Cutting the fourths into 3 more pieces gives us 3/12. So therefore 11/12. All right. Now, there's more concepts here when it comes to equivalent fractions and common denominators. Common denominators are as simple as doing this. 50 centimeters plus 5 meters, we cannot add those. We cannot say 54. That's definitely not true. We would want to convert the centimeters to meters. All right? Same thing with the feet plus the inches. We have to change these. All right? So 50 centimeters plus 4 meters becomes, well, 5 meters, because there are definitely, actually this is 0.5. You know what we'll do? Let's change this to, let's just change this to 500 centimeters so that we can keep it consistent here. Let's change this to 500, because there's 100 centimeters in a meter, so there you go. We'll just do 500 centimeters plus 4 meters will give us 5 meters plus 4 meters, which is 9 meters. Okay, now we have 2 feet plus 15 inches. Well, we would convert the feet to inches this time, and we'll get 24 inches plus 15 inches, which is 39 inches. So yes, you can describe this as 39 inches, or 39 inches converts to 3 feet plus 3 more inches. Now look at this. This is like your improper fraction, if you will, because you're using inches when you have 12 inches in a foot, so therefore you could use feet. So this would be like the improper fraction. And then this is like kind of like the mixed number, 3 feet and 3 inches, or in other words, 3 1/4 feet. Then we have 3 years plus 5 months. Well, 3 years is 36 months plus 5 more is 41 months. Then if you wanted to, we could convert this to weeks, and we could multiply that by, if there were exactly 4 weeks in every month, we would multiply by 4, so we'd get about 160. However, we're probably better off converting the years to days, and then converting the 5 months to days, and then converting that up to weeks. You'd probably get a little bit more of an accurate answer. But nonetheless, the whole idea of common denominators is precisely this: common denominations, common units of measure. That's the reason for common denominators. And in the next videos, we are going to add and subtract fractions by getting common denominators. And for the people that are on YouTube, guys, this is the website where everything is there. Everything in mathematics is going to be there at some point. We're just going to do this all one video at a time.